of the machine, it is the importance of this lies also in the fact that there is a theory question also, which is very often asked in the examination, whether it is on the safety aspects of the machine or simply just describing the machine. And in the practical examination as well, I think most of the students are asked about the machine, what the examiner is interested specifically is how well you know about the machine, because if he is convinced that in case you know the machine very well, so that means you have worked very well and you are quite meticulous in your working. Over to you, Dr. Akhilesh, please.
Thank you, sir. Before I start, I must thank Baljeet sir, because what all I will be teaching today is because of him. During my postgraduate days, he only taught us machine in the various PG assemblies, and we all grow by seeing his presentation. Thank you, sir. Yeah, so coming on to anesthesia machine. Why we need to know about anesthesia machine? As sir has rightly said that you can get some theory question in the exam, like safety features in anesthesia machine and how you check anesthesia machine. There are ASA guidelines also in 2008. There was no fresh guidelines after 2008, but yes, there was a guidelines in 2008, which talked about how to check the anesthesia machine and who should check and whether you should check it before the start of a day or before each case. Another thing which can come as a safety feature, they can get a short note on Link 25 system. So that's why you should know about it. And besides that, it is very important in a table viva. Sir has rightly said that it is expected that at least you should know the machine before you start giving anesthesia and before they make you pass the exam. So coming on to the history of anesthesia machine, it was invented by Henry Edmund Gaskin Boyle in 1917. That's the why name of Boyle machine came. And what actually he did is that he had modified the Gotherme machine. And it was Gotherme who had invented the Gotherme machine in 1912. But sadly, he's not known much and people talk about H.E.G. Boyle. But yes, machine, the basic template of machine which we use it is Boyle's machine. So starting with the machine, there are two components of a machine. One is electrical component and the pneumatic component. For electrical component, you need electricity. A machine can work without electricity by the flow of gases. So it is not essential that there has to be electricity for running a machine. So, but yes, these days we are getting all the modern machines and they have an electric component which has master switch, power failure indicator, reserve power, electrical outlet, circuit breaker, data communication ports. They can all integrate your monitors and inhalational agent and all that values in the machine itself. So we'll be not talking much about electric component. I'll be talking about the pneumatic component. So whenever you are asked about the machine, it is very much expected that you should know at least what are the three zones. There's a high pressure area, there's an intermediate pressure area, and there's a low pressure area in a machine, and what all things of the machine, what all components of a machine comes in which area. So coming on to high pressure area, it's cylinder pressures. We'll talk about it. This is a small schematic diagram of how the machine looks. There are oxygen cylinders, there are nitrous oxide cylinders, there are pressure regulator, fail safety valve, oxygen supply failure alarm, flow meters. I'll be taking this picture again after I complete my talk. And again, this is the Boyle's machine and all those things you can see in this machine. So we'll again be discussing it after the end of my talk. So coming on to the high pressure system, here things are in high pressure. So machine part comes as a yoke hanger, yoke block, cylinder outlet yoke, cylinder pressure gauge, and pressure regulator. Cylinder per se is not a part of a machine. So when you talk about high pressure system, you say that attachments of cylinder with the machine. So that's a yoke hanger, yoke block. We'll talk about each part. There's a body, which is a principal framework. This is the body of the yoke hanger. Then retaining screw, there's a screw, this you can see, this is a retaining screw. This is the yoke assembly. The cylinder gets into it and then it is retained. So nipple through which the gas enters the machine, this is the nipple. And the nipple carries quite a big significance to avoid the calamities. So there is a nipple, there is a washer. These are the things through which the gas goes from the cylinder into the high pressure system of a machine. Then there is another important thing, pin index safety system. This is again a must thing you should know. The thing I like to emphasize is when we talk about the pin index system, the pins are there on the machine. They are not on the cylinders. Cylinders have a hole for those pins. So it should be very much clear to you that when we talk about pin index, pins are on the machine. See, these are the pins which are on the machine. And these are the holes we find in the cylinder. So it should be clear to you that pins are not there in the cylinder. So coming on to the pin index system, there are two holes on a cylinder and pins are there on the yoke assembly. Every gas cylinder has two holes except Antonox, which has one hole. And again, I like to emphasize again also that pins are a part of a machine, not cylinder. Some people, some examiners who like numbers, so they can ask what is the diameter of that pin and how much length is the pin. So diameter is 4 mm and length is 6 mm. And these are the pins and they form an angle of 60 degrees. Okay. And pin number 7 is in the center. So 7 hole positions are there in a circumference of a circle. And the diameter of a circle is 9 by 16 inch. Again, a number. This is when we talk about the cylinders, they have holes. This is oxygen 2,5 position, nitrous oxide 3,5, air 1,5 and Antonox, which has only one position. And that's a central position of number 7. Now, why I talked about those pin index system? Because yes, these pin index are a safety feature, but they can be bypassed. Here you put a here you put a washer. So just imagine if you put 3 washers here, then the pin index will not work. So there's a double washer, 3 washer, yoke is put upside down. Wrong gas filled in a cylinder, pins are damaged. So we'll be talking about that, why this becomes more important and why we have other safety features. Like we talk about oxygen analyzer, when we talk about the checking of machine, they become important because there had been casualties where the pin index system was bypassed. And there was not many casualties alternatively in the same hospital. So another thing which is usually asked is, I'll talk about it. This comes after the cylinder, the yoke assembly, there is a cylinder pressure gauge. So again, what is pressure gauge? It is a hollow metallic tube. This is the hollow metallic tube, which is attached to the adjustable link. When the gas comes into that tube, the tube gets straightened up. And once the tube gets straightened up, it moves the adjustable link and this link is connected to the lever. And then we can see the movement of the needle. So yes, this is nothing electronic in it. This is something which is mechanical, pneumatic. As I talked that the initial machines were based on pneumatic system only. So this is the tube which comes and once it goes and once the cylinder is closed or a pipeline is taken off, it again gets curved and the needle again comes back to a normal position. Then we talked about in a high pressure system, we talked about the cylinder yoke assembly. Then we talked about the pressure gauge. Now cylinders are at high pressure. So the pressure has to be reduced. So it reduces the high and variable pressure delivered from a cylinder to a lower and more constant pressure. The cylindrical pressure is usually variable. So there comes the role of a pressure regulator. And the pressure at a regulator outlet is set lower than the pipeline pressure. This is a very important concept. I will be talking once I finish with this. This is how the pressure gauge, the regulator works. There's a formula P1A1 is equal to P2A2. If you increase the pressure, decrease the area, the product is equal to if you decrease the pressure and increase the area. So yes, there is a high pressure inlet. The area of contact is this. Then you increase the area, so the pressure reduces. So this follows the principle P1A1. Sometimes it is asked in the exam that draw a diagram of a pressure regulator in the machine. So it's a simple thing, you should know it. So coming on to intermediate pressure system, there are pipelines, pipeline inlet connections, pipeline pressure gauges, oxygen pressure failure device. We'll be talking each of them, auxiliary power output, oxygen flush and flow meter assembly. Coming on to the pipeline inlet connection, the entry points are gases. These are attached on the walls and pipelines are attached. There is a safety connector disc diameter index safety system, and each inlet contains a unidirectional valve. Again, when we talked about the pin index and the valve assembly of a yoke assembly, so there it also promotes unidirectional. Otherwise, the pressure will go back to cylinder. If you have attached two cylinders and open one cylinder and open both the cylinders, then gas can go from one cylinder to another cylinder. So to avoid that, there is a unidirectional flow. So again, in the pipeline system, there is a unidirectional flow. This is pipeline inlet connection. And as we have pressure gauges on the cylinder, we have pipeline pressure gauges, and they are required to monitor the pipeline pressure. They are usually on a panel in front of a machine. See, these are the panels. So this is oxygen. The pressure is usually 60 psig. We keep it around 50 to 55. Nitrous oxide and air. So they are usually on the panel in front of a machine, and the pressure should be between 50 to 55 psig. Now the question I was talking about, suppose you have the pipeline connected to the machine and you have a cylinder which is open. So machine will take oxygen from which area? From the cylinder or from a pipeline? Because this point has been very much emphasized in the new DOSH edition. They say that if you have connected both the things, you have connected the pipeline and you have connected the cylinder, the pressure of a cylinder after a pressure reducing valve is to be kept below the pipeline pressure. I've talked about it. So the machine will prioritize, and machine will preferably take the gas from the pipeline. It will not take the gas from the oxygen cylinder, because we keep the pipeline pressure a little higher than the pressure in the oxygen cylinder. Then the question arises, okay, that if the machine takes gases from the pipeline, why you close the cylinder after checking it? They always say that after checking a cylinder, you should always close a cylinder. This is again asked in the exams. And the reason they say is that yes, machine will preferably take gas or oxygen from the pipeline. Suppose there is a fall in pipeline pressure, then there will be no alarm. Machine will by default take gases from the cylinder. And when you will get alarmed, when there is cylinder is empty and the pipeline pressure is low. So that's the reason why you should always close the cylinder after checking. Otherwise, machine will by default take gases, oxygen from the pipeline. But in case there is a slight fall in pipeline pressure, because the oxygen cylinder pressure after pressure reducing, the pressure comes out to be around 40, 45. So then if the pipeline pressure goes below it, it will start taking oxygen from the cylinder and you will not get alarmed. You will get alarmed when you find that the cylinder is empty and pipeline pressure is low. So it should be kept very much, it should go in a very important way, because it has been emphasized 3 or 4 times in the DOSH. Okay. Then we talk about oxygen pressure failure devices. This is oxygen pressure failure device. In this device, the important thing is it consists of 2 parts: oxygen pressure safety device and oxygen pressure failure alarm. So when we talk about oxygen pressure safety device, it interrupts the supply of other gas if oxygen supply pressure decreases. We'll be discussing it, and it's a pneumatic system. Again, no electricity is required. See, this is the oxygen pressure failure safety device. This is where the oxygen goes. Once the oxygen goes here, it pushes up the lever. And when it pushes up the lever, then there is an entry of nitrous oxide to the nitrous oxide flow meter. Okay. So suppose there is a low pressure of oxygen, so it will not push the lever. And then there will be no entry of nitrous oxide. So the entry of nitrous oxide into the machine system is dependent on the concentration or flow of oxygen which is there. Now, there are some fallacies in this also. It can be bypassed. Suppose it depends on the flow of oxygen only. Now, suppose a cylinder of nitrous oxide is placed in place of oxygen by bypassing the pipeline system. So then the nitrous oxide will go. It does not sense about which gas it is. So there comes the role of oxygen analyzers. This talks about only of the flow. It says that yes, if this gas comes and there is a flow, then it allows the other gas to go. Another way this system can be bypassed, there is something called a difficult kind of a question which can be asked in the exams. Suppose you pressurize the system. You open up the cylinders, attach, stop the flow meters, so the system get pressurized. So this is there. and then you start the nitrous oxide. So nitrous oxide will automatically go without going on the oxygen. So this is somehow, this system can be bypassed. And the important thing is this is flow dependent. The important take home message is this oxygen pressure failure safety device is a flow dependent device. So there comes the role why we use talk of oxygen analyzer. Then after oxygen supply safety device, there comes the failure alarm. Again, no electricity is required in the initial machines, Boyle's machine. It is a pneumatic alarm. There is a small hole. So whenever there is a decrease in concentration of oxygen, the gas goes through that hole and there's a whistle. Will sound within 5 seconds of oxygen pressure falling below 30 psig. So again, if the pressure goes below 30 psig, this lever goes down and nitrous oxide supply gets interrupted. Then another thing of intermediate pressure system is oxygen flush. So what all we have talked about pipeline inlet connections, we have talked about pipeline pressure gauges, we have talked about the oxygen pressure failure device, then we'll talk about the oxygen flush. This is the oxygen flush. Another important question which is asked in the exam is that how much flow of oxygen is given out from the oxygen flush. So it is 35 to 75 liter per minute, and that's a good amount of flow. So if it is not used judiciously, that can lead to barotrauma also. So that's a high 35 to 75 liter per minute of oxygen, which goes unmetered flow directly into the common gas outlet and is usually labeled as O2 plus. If you find that you will, there's always a O2 plus. It's labeled on the machine that this is O2 plus. So this means that this is the extra oxygen which comes through the oxygen flow. And in most anesthesia machines, the oxygen flush can be activated regardless of whether the master switch is turned on or off. So this is how the oxygen flush works. This is when it is not activated, the oxygen comes. And another important thing is that oxygen flush is a part of intermediate pressure system. It should not be confused because it is just lying near the common gas outlet, and it should not be confused as a part of a low pressure system. It's a part of an intermediate pressure system. So the oxygen in and there is oxygen flush is not activated, so it doesn't go. But if you press that oxygen flush, the oxygen goes from here and from the flow range of 35 to 45 liters per minute, that much of oxygen goes unmonitored. So as I have talked that the pressure of that oxygen is around 400 kPa. We are talking about the pressures of 50 psig, 60 psig. So that can cause barotrauma. Further, since the high amount of pressure, high amount of oxygen goes from the machine to the common gas outlet, the percentage concentration of an inhalational agent decreases. So it causes awareness also. So it is also asked in the exam that what are the usual side effects of using oxygen flush. Another important thing and one of my favorite things is auxiliary outlet. See, if you can see this photograph, there are small connections here. These are the auxiliary outlets. And these auxiliary outlets are also a part of an intermediate pressure system. Okay. Now coming on to this, you must have seen this in your machines. This is the bellow, the ventilator. Have you ever imagined that why this bellow moves? Because there is no electricity. It has to move pneumatically. So how this bellow moves? There is no negative pressure also. So when in inspiration, the bellows goes down. Think why they goes down. It is because of that auxiliary outlet. The auxiliary outlet gives the oxygen, and that oxygen is used to drive the bellows. So they are pneumatic bellows. Let's see. There are small holes here outside the bellows. So suppose you target the tidal volume of 500 ml. So 500 ml of oxygen will come out from these holes and press these bellows. And these bellows contains, inside of these bellows are the anesthetic mixture. So that much amount of gas will go from a common gas outlet to the patient. So important thing is that that much oxygen, 500 ml per breath, is used only to drive the bellows. Now you'll recall one thing, that whenever there is a fall in a pipeline pressure and when we open up the cylinder, technician always asks us that yes, take the patient on hand. Don't ventilate through the ventilator. Because if we ventilate this ventilator, through the cylinder, then every breath 500 ml of oxygen is getting wasted. So whenever you are using a cylinder, avoid using this bellows system. So these auxiliary outlets are also used many ways. One is for driving the ventilator. Another thing is it gives an extra oxygen outlet. You can use it for many ways, and you can always use it when we can use high frequency ventilation. It is advisable not to use high frequency ventilation from the common gas outlet. So that outlet can be used. Now come the second stage pressure regulator. There's an additional pressure regulator just upstream of the flow adjustment controls. These are the flow adjustment controls, flow control knobs. So just upstream, like clear at this point that when you read the book, it talks about upstream, downstream. So I always used to get confused. What do you mean by upstream? What do you mean by downstream? Anything distal to something is downstream. After that, down to that. And anything proximal to that thing is upstream. So the second stage pressure regulators are upstream. They are before the flow adjustment controls. And they reduce the pressure to around 26 psig for nitrous oxide and 14 psig for oxygen. And not all anesthesia machines have this device. Coming on to the another part of intermediate pressure system is flow control knob. These are the flow control knobs. So it regulates the flow of oxygen, air, and other gases to the flow meters. And there is one flow adjustment control knob per gas. And it has to be adjacent to be identifiable with the associated flow meter. I'll talk about this. This is the flow control knob. So these are color coded. These are touch coded. In case of oxygen, you will find always this flow control knob to be fluted. So this is the fluted appearance. And the knobs have to be opened in an anti-clockwise manner. In anesthesia, majority of the things work anti-clockwise. So if you turn it clockwise, it will move inward and close the outlet and stop the gas flow. If you turn it counterclockwise, the stem will move outward to increase the gas flow. And there comes the use of a flow meter tubes. Safety features, there are stops for on and off maximum positions. It has a fluted appearance, and the flow control knob of oxygen is larger than any other gas. These knobs are placed higher than the platform so that it doesn't get opened up accidentally. And they should be closed when not in use. So we have talked about the high pressure system. High pressure system consists of a yoke assembly, consists of a pressure reducing valve, oxygen gauge. Then we talked about the intermediate pressure system. In the intermediate pressure system comes the pipeline pressure gauge, then oxygen failure safety device, oxygen failure safety alarm, oxygen flush, and the auxiliary oxygen outlet. So after that, now comes the low pressure system. So low pressure system is located between the flow control devices and the machine outlet. And the pressure is slightly above atmosphere and variable rather than a constant one. So there are pressure fluctuations, the flow from a flow control valves and the presence of back pressure devices. We'll be talking about these back pressure devices. Now these flow control tubes consist of various things. There is a variable orifice, the flow meter. They have a variable orifice. It consists of a vertical glass tube with internal taper with its smallest diameter at the bottom. The tubes are not straight. They are inclined at an angle in the vertical. Contains an indicator which is free to move up and down based on the flows. Again, I like to emphasize that yes, these machines do not require electricity. They work on pneumatic system. So when we talk about each bobbin of this device, there's a downward force which makes this device to go down, indicator to go down. And there is an upward force which pushes it up. So based on that, taking on the consideration that what is the weight of that indicator, they are designed. So how the flow goes through the flow meter. And the flow rate depends on various things. How much is a pressure drop across this constriction, the size of annular opening, and the physical properties of a gas. The flow meters are different for each gas. You cannot use oxygen flow meter for nitrous oxide or nitrous oxide flow meter for oxygen. Coming on to the flow meter tubes, there are two types of tubes. One is a single taper and other is a dual taper. The single taper are usually used when there are two flow meter tubes, one for a low gas and one for a high gas. So they can adjust accordingly. But yes, if you are using a single flow meter tube for both low gas and high gas, so then it comes as a dual taper. Indicator when at what point you should read it. So they say that the widest diameter of the indicator is a point where flow should be read. So flow should be read here, here, here. But what about in a circle? So in that, it has to be read at the center of it. And you will realize one thing, that there is a small point which is there on that indicator. That points tell us that yes, this is rotating every time. Whenever there is a gas flow, it keeps on rotating. So you should always know that yes, it is rotating. This means that this much flow is going on. Otherwise, it can stuck with the walls. So these are tubes in series. This is the flow control valve. This is the stopcock. And it goes, there are two tubules, and then it goes to the common manifold. Another thing which becomes important is that there are flow meter tubes, oxygen, nitrous oxide, and air. Fine. So where should be the oxygen flow meter tube? So it says it should be distal to all the tubes, and oxygen flow meter should be kept nearest to the outlet. What happens if we keep it before it, air or nitrous oxide? Suppose there is an oxygen which is going, and there is a hole, there is a leak in the air flow meter tube. So the oxygen will go from here. So the effective concentration of oxygen, now we have gone beyond the stage of a oxygen flow control safety device. So now whatever we give from here, it will go. So you give the oxygen at a flow rate of around 10 liters per minute, but effectively it is reaching here at the rate of around 3 liters per minute. And the nitrous oxide is, suppose you give the patient 6 liters of 6 liter per minute of oxygen flow and 4 liter per minute of nitrous oxide flow. And the 6 liter per minute goes from here, it leaks, and here it goes like a 3 liter per minute of oxygen and 4 liter per minute of nitrous oxide. So it becomes hazardous. Again, if you keep it in this way, it becomes problematic. So it has to be kept distal to all the flow meters, so that the effective concentration of oxygen doesn't hamper. So there are certain safety things. There's the hypoxia prevention safety device. It consists of two things. One is minimum mandatory oxygen flow. Whenever you open the machine, the minimum flow of oxygen has to be 50 to 250 liter per minute. Okay. And another thing is link 25. Now, what is this link 25? This is link 25 proportionating system. You can get a short note on that also. Both the knobs of oxygen and nitrous oxide are connected by a linkage. Then it is asked in the exam that how much tooth sprocket is there. So there's a 14 tooth sprocket fixed in the nitrous oxide control knob and 29 tooth sprocket attached to the oxygen control. This means that whenever nitrous oxide is open, oxygen will automatically gets opened. So this is the important thing, that this is important to prevent the delivery of a hypoxic mixture. Then again, I came to the thing that unidirectional check valve. It is located between the vaporizer and common gas outlet. What happens when we give the anesthesia? You give positive pressure ventilation. Now that positive pressure goes to the patient, and it can go from the common gas outlet backward also. So to avoid that, there is a unidirectional check valve, so that whenever we give positive pressure ventilation, it should not go in the backward direction, like in case of a breathing circuit or oxygen flush. So we use the unidirectional check valve. It carries a significance when we talk about the machine checking. Then the common gas outlet, it receives gas from the machine and delivers to the breathing system. And as I've talked, that it should not be used to administer supplemental oxygen and provide jet ventilation. So coming on to the picture I've talked about in the beginning. Now see, these are the nitrous oxide cylinders. These are the oxygen cylinders. This is cylinder pressure gauge. This is pressure regulator, first stage pressure regulator, which reduces the pressure of oxygen. Here comes the oxygen pipeline supply. We have talked about it that we have to keep it above this pressure so that machine preferably takes gas from the oxygen pipeline supply. There comes the fail-safe valve. Here goes the oxygen. Here comes the nitrous oxide. Then there is oxygen failure safety alarm and oxygen failure safety device. This is the device we have talked. See, it requires the flow of oxygen to allow the flow of nitrous oxide. And then it goes to this flow meter. Oxygen goes through this flow meter. Then from these flow meters, these are vaporizers. And there comes the common gas outlet. Now see this. This is the boils, and this is asked in the exam. These are the pressure control knobs, pressure gauges. Then these are the pressure control knobs, pressure regulators, you can call them. And here comes this. And this is oxygen failure safety device. It allows the movement of one gas based on the flow of other gas. And then it goes and and there it goes in the flow meters. Oxygen flow meter, nitrous oxide flow meter, and then this is the common gas outlet. So another thing which is asked in the exam is what are the anesthesia machine safety features? So to start with the wheels, there's a large caster wheels. Why they are used? Because they're anti-static. The front wheel is locked so that machine doesn't go haywire. Then come on to the cylinder. Cylinders are color coded. There's a pin index system in the machine part. Then there are pressure gauges. And there's a provision of attachment of 2 oxygen cylinders and 2 nitrous oxide cylinders. So you can have a bypass cylinder also. And then there's a pressure reducing valve which reduces the pressure. Then coming on to the pipeline, there are diameter index safety system for pipeline. Then oxygen failure safety device, oxygen failure safety alarm. Coming on to the flow meters, they are color coded, touch coded. There are sidebars in the minimum and maximum position. The minimum distance between 2 flow meter knobs is 25 mm, and there's a bobbin. Again, coming on to the bobbin, it's a color coded bobbin. I've talked about the dot, fluorescent dot on the bobbin. Then oxygen is always downstream of other gases. We have talked about this also. Then there's a color coded calibration in the flow meter tubes. Oxygen, the calibration is 100 ml per minute to 8 liter per minute. Vis-a-vis in the nitrous oxide, the calibration is 200 ml per minute to 12 liter per minute. And then there is oxygen flush as a safety device and auxiliary oxygen outlet. Coming on to the low pressure system, there's a minimum mandatory oxygen flow, link 25, non-return pop-off valve, and unidirectional check valve. So these things come into the anesthesia machine safety features. This you should know, it is asked in the exam, and this is the basic which is expected out of you. Coming on to the machine check, there are guidelines from American ASA in 2008, which talked about. So first item, there are 14 things. First is, it has to be done daily. Verify auxiliary oxygen cylinder and self-inflating manual ventilation device available. Make sure that the embo bag is there. Embo bag is working. This is the first thing you should know. Whenever you enter into the OT, you should look at the embo bag. Yes, embo bag is there, and ensure the E-type cylinder is full. Coming on to the second item, it has to be done before each use. 2 things are required before you touch the machine. One is embo bag and another is suction. So verify patient suction is adequate to clear the airway. And it says that you should have a working suction. And important with suction is that you should have a tubing of appropriate length also. And the oral suction should be there. Coming on to the third item, which has to be done daily, that to make sure that the AC power is verified if you are using the electric machine, and the electricity is there to supply the subsystems like desflurane vaporizer also. Coming on to the item number 4, which has to be done before each use, is presence of monitoring supplies, functional test of critical monitoring equipment. And yes, the alarms are working, all the things are there in place. Now, verify the pressure is adequate on the spare oxygen cylinder. They say that if you are using a machine on a cylinder, then you should always have a spare oxygen cylinder, which should be the half of the capacity. So it should change the cylinder when the pressure goes below 100 psig. And if you are using the machine on the pipeline, then you should have a spare oxygen cylinder, which should be full. Then verify the pipe gas pressures are 50 psig or higher, otherwise it will take the gas from the cylinder. Ensure the auditory and visual alarms that warns the diminishing oxygen supply pressure. Then verify the vaporizers are adequately filled and filter ports are tightly closed. One of the most common cause of leak in the machine is the vaporizer area. So ensure adequate supply of anesthetic agent should be there, and loose cap on a vaporizer port can lead to leakage. Then item number 8, verify that no leak is present in the supply line between the flow meter and common gas outlet. This is the, now I'll briefly discuss about this. This is the low pressure system between the flow meter and common gas outlet. And the low pressure system is the most vulnerable system to leak, because it goes through the flow meter tubes, it goes through the vaporizers. So it is most vulnerable to leak. So we do a negative pressure leak test. It is also known as a universal leak test. It is asked in the exam every time that what is the universal leak test, what is a negative pressure leak test, and it can detect leak as small as 30 ml per minute. So how you perform this? Verify the machine master switch and flow control valves are off. Attach a suction bulb to common gas outlet. This is a suction bulb and you attach it to a common gas outlet. Squeeze bulb repeatedly until fully collapsed. Verify the bulb stays collapsed at least 10 seconds. Squeeze it and leave it. It should stay collapsed for at least 10 seconds. If it gets inflated within 10 seconds, then this means that there is some leak in the low pressure system. And important thing is that you should do this test with all the vaporizers off. Then you should do this test with one vaporizer opened, then close it off. Then you should do this test with another vaporizer, because vaporizer are a very common source of oxygen leakage. Then check the scavenging system. Then verify calibration of oxygen monitor. Here comes the role of an oxygen analyzer, because this becomes important, because all the safety systems are flow controlled. So use oxygen sensor analyzer. And how you check it is okay or not? You do one thing, you check the low oxygen concentration alarm by setting the low oxygen concentration alarm. You keep the alarm from 21 to around 25% and check it on the room air. So when you expose it on a room air and if it alarms on a 25%, this means that this sensor is working. Then verify the carbon dioxide absorbent is not exhausted. Breathing system is pressurized and leak free. Now, how we do this test? Set all the gas flows to 0 from the flow control knobs. Make all the gas flows at 0. Close APL valve and occlude the Y-piece. All flows are 0. Close APL valve and occlude the Y-piece. This is the Y-piece. So occlude the Y-piece, close APL valve, and then use oxygen flush. Here he is using the oxygen flush. Once you use the oxygen flush, the systems get pressurized, and there is a reading of 30 psig on the gauge. This 30 psig should remain for at least 10 seconds. 10 seconds because very important in checking of machine. So this 30 psig pressure should remain for 10 seconds. And if it goes down before 10 seconds, that means that there is some leak. So important thing is that this is the positive pressure leak test. What we talked about earlier is a negative pressure leak test. And this leak test cannot be performed in the machines which have a check valve, because the positive pressure will go back. So to sustain a positive pressure, it cannot be done in the machines which have a check valve. So verify the gas flows properly through the breathing circuit during both inspiration and exhalation. For this, we use a flow test. Place test lung on the patient end at the Y-piece, and this is the breathing bag. Keep the machine on a bag mode or manual mode of ventilation. Ventilate the artificial lung with the breathing bag. Ventilate this lung. So this, here it goes, it gets inflated when you press it. Once you press it, check on the valves. This is the inspiratory valve, this is the expiratory valve. So once you press it, the inspiratory valve opens up and expiratory valve is closed. Coming on to the opposite. Now you press this and see this. So now the inspiratory valve should be closed and expiratory valve should be opened up. Another thing is document completion of checkout procedures. And they say that these are the basic few things you have to check. If you don't go by those 15 steps, these are the small 6 things you should ensure that monitors are functional, capnograph is present, oxygen saturation by pulse oximeter is present, flow meter and ventilatory settings are proper, manual or ventilator switch is set to manual, and vaporizers are filled. Now, some people say that, yes, we talked about the machine, but anesthesia is not only about the machine. It's about all other things. So they say that there's a MS made checklist. This again can be asked in the exam, which is MS made checklist. It's a machine, suction, monitor, airway, check your intravenous line is secured, drugs are available, and if you are attaching any additional monitors, so make sure that they are okay. Thank you.
Thank you so much, Dr. Akhilesh. Friends, I'm sure you must be thinking that whatever I spoke about Dr. Akhilesh with regard to his competence and academic achievements was much less than what he actually deserved. It was a very comprehensive coverage of the machine and the various aspects which are important from the point of view of the examination. So he has covered it all. I think we'll have question answers and whatever clarifications that you may have at the end of the next small talk. And that talk goes on soda lime.